All right. So yeah, welcome. Is this thing working? Yeah, cool. So yeah, welcome to MYOB. At MYOB, we, as part of our platform engineering team, we offer our delivery team something called managed infrastructure solution, and that managed infrastructure solution is backed by Kubernetes. Now, as you operate Kubernetes clusters over the period of time, you gain certain expertise, and then you feel a need to extend the cluster to make it do things which generally an ops person would do. And Kubernetes has a very good concept, or it's a concept around the ecosystem, which is called the operator pattern. And combine it with the CRDs, you can really improve, or you can really make your ops life simple and efficient. And you can make your developer workflow very simple and efficient. Your developers don't need to talk to certain people branded as ops and get things done on the clusters and everything. So yeah, today we'll just talk about operators and CRDs in general, some concepts. I'm going to keep it like a low level as well, because not sure how many people have played around with operators. Although, quick show of hand, how many people are operating Kubernetes clusters, administrative clusters? Oh, cool. Of course. Doing whole, but so yeah, it will be a fairly low-level talk where I'll go through the concepts as well, so that everybody's familiar and is following what we're doing. Yeah, by the way, I'm Prateek. I am one of the engineers, as I said earlier, and that's a Twitter handle. You can follow me. I do not tweet personal stuff. It's all technical. Sometimes it's personal, but it's technical. It's technically personal. So that's the agenda for the talk today. Is we'll look at what we're doing with Kubernetes at MYOB, and then we'll go over a few concepts like custom resource definitions, CRD, controllers, and then actually look at what is operator pattern. After that, what we'll do is we'll look at an example/demo. I have to tell you this: my demo was working until this morning. Swear to God, I did a dry run yesterday, I tested it today, but now Minikube on my machine is stuck. But we'll give it a shot, we'll see. But even then, we'll talk about the examples. So at MYOB, we've built a couple of operators so far. One is called the DB operator, and the other one is alerting rule operator. So we'll walk through alerting rule operator because it's very simple one. And I'll go through what it is, why it is required, and what's the, what problem does it solve. So, very quickly, let's start with Kubernetes at MYOB. So, what are we doing with our Kubernetes cluster? Our Kubernetes cluster is deployed on AWS. We use K8s to deploy at the moment. It's been an interesting journey with K8s. K8s has enabled us to get off the ground pretty quickly. But now, we are at a level where we are seeing some edge or boundary issues with K8s as well. But so far, it has been a good journey with K8s. We deploy our cluster in a highly available master deployment. So we've got 5 masters, which look after the n number of nodes and everything. That's how you should be deploying in production. A single master is not a production-worthy cluster, and there are issues with 3 masters, which is our scope of this talk. Oh no, there's one thing. The other thing is, and this is something we're doing slightly differently, or this is something new we're doing at MYOB, is a concept which is at the very bottom there, Shattering Spaces, but it is actually a precursor for multi-tenant cluster. And our architect in our team, Paul, who's here as well, he came up with a theme called Shattering Spaces. Now, let me just tell you what this means, because it is important for the purposes of the demo and everything. So, what we do is each of the delivery team at MYOB gets a namespace on our cluster. Now, namespaces, as you guys are all familiar with, are a kind of a virtual cluster on your actual physical cluster. So, it gives you a nice bit of separation. So, 2 different delivery teams, they cannot, cause issues with other delivery teams, and they don't have to, they don't interact with each other's resources. So, namespace is a good way of separating things. Generally, people separate environments based on namespaces. So you'll have a test environment as a namespace, dev environment as a namespace, but we separate environments based on cluster, virtual cluster, whatever, clusters. And then we separate delivery teams using namespaces. Now, interesting thing was when we were going through it, we wanted to give as many things out of the box as we can to our delivery teams. We didn't want them to think about monitoring, logging, alerting, dashboarding, all of this. We wanted to provide them all of these features out of the box. But if we deploy them with their namespace, they will have access. As soon as somebody has access, they want to poke at it. And we were thinking about it was a solution, and Paul came up with something called shadow namespace. So what we do is, alongside a namespace for a team, we deploy another namespace called shadow namespace. We prefix it with shadow or suffix it with shadow. Not prefix goes first. And in that shadow namespace, we provision all of this monitoring, alerting, dashboarding infrastructure. That's how we give them many things out of the box, which they don't even have to worry about. All they have to do is deploy their application, they'll get things out of the box. Now this is important for the purposes of the demo, which I'll touch on when we get to the demo. And other things I've already said, like what namespace allows us to do is apply resource quotas, which takes care of the noisy neighbor syndrome. So somebody in another namespace can't just trample over your resources. It's separate. And yeah, HTTPS out of the box. We use Lego at the moment for it. So that's how the cluster is structured at MYOB. There are many other details, but not really relevant for the purposes of talk. Now, once we on a cluster, let's go through some basic concepts which will be required for demo and which are important for the referential integrity of the talk. The first things first is custom resource definition. What's a custom resource definition? In order to understand custom resource definitions, we need to first understand what are resources. Resources are your pods, your config maps, your secrets. All of these are Kubernetes resources. They're part of the Kubernetes API by default. Anyone who creates a cluster, who stands up beneath you, will have access to these API or resources by default. But what custom resource definitions let you do is extend that API so that you can build a functionality on top of it. One of the very powerful features of Kubernetes is the extensibility. Other platforms, for example, ECS or something, they don't have this feature. And you are bound in a shell. Okay, you can only do this. But with Kubernetes, you can just extend it and do many, many, many things. So, as the definition, I think I took it from Wikipedia somewhere, or their documentation, I don't remember. But that's a proper definition. And it just says CRD is just extending the APIs. You can do a lot many things, which we will see while our demo. The next thing to talk about is obviously controllers. Now, you've got defined a custom resource definition. What are you going to do with it? If there's nothing, nobody is looking after it, there's no point of defining custom resource definition. There's no point of having an API extension if you can't do anything with it. So, Kubernetes controllers are an interesting concept, and every resource in Kubernetes at this point has a controller. For example, pods, which are a resource, have a pod controller. And as that definition says, that is definitely from Wikipedia, so I don't trust it, but whatever. It's just when you declare a state, it's a controller's job, it's a constant loop which makes sure that whatever you said you want, it happens in the cluster. Pretty straightforward, simple, nothing complicated. It's just you created something, you said to the Kubernetes API, I want a pod, there's a controller in the background which will make sure whatever you declare is what you get. Now, controllers are a controllers are important part of operators as our CRD, which we will look at shortly. So the next thing is now the actual operator pattern, which was the title of the talk. Yeah, operator. What is an operator? So it was a term which was coined by CoreOS, and their definition was pretty straightforward. Like codifying human operations knowledge is an operator. That is pretty good. I just simply, the second point, that's just how I see operators as. They're just codified ops knowledge and tasks. What do I mean by that? Now, for example, on a Kubernetes cluster, if you have a resource which the data needs to be backed up constantly and something needs to happen after data backup has happened and something needs to be alerted after that, you would generally, traditionally, you would have a person who would do these things. They are branded as ops people. This is an ops task. We don't do it. We are developers. We don't touch this thing. And it's when you involve a human in the process, there are issues. You will definitely run. Its failure is certain. It's not a question of if, it's a question of when. Failure will definitely happen. And we've heard of many examples, like the GitLab thing. How many people heard about the GitLab thing when someone just deleted the shit out of their system? And, sorry. It was a human error, and nobody should blame a person because it is not the person's fault. It is the system that allowed the person to do this. It's the system's fault. So codifying those things into certain things which can just operate. Software I can trust. Human, yeah, depends. So if I can trust the software to do a backup and to upload it consistently, because obviously I would have written unit test for it. I would have tested it before. But human, can I test? No. And the fundamental concept here that you can just codify somebody's job, and that is, you can trust it's repeatable, just makes your ops life simple, doesn't it? It's like you don't have people coming to you, oh, can you do a backup now? I don't want to do that. What if I'm in a bad mood? I'll just RM minus RF, deal with it. Simplified ops life, efficient ops life, because you want your operations people to concentrate on other important things. Building proper infrastructure rather than doing a backup for someone. Or just taking a MySQL dump of something and giving it to you. I don't want to do this. Anyway, so that's the underlying concept of pattern. Now these three things, example already? Okay. These three things, they constitute the operator pattern. How? So first of all, you define a custom resource, how you want to extend your API. For example, let's work on a proper example. Let's say, for example, there is a publicly available endpoint. This is your service, and it keeps on changing whenever you deploy. You don't have no control over it. It just changes. And 5 or 6 of the services in your cluster are dependent on that endpoint. And they're in different namespaces, and they have a config map and everything. Now, in traditional ways, there would be a person a poor guy who did the deployment for this external dependency, takes the new URL, copies it into config map in one namespace, the second namespace, the third namespace, forgets the fourth. That's a common thing that used to happen. It still happens. You can combine, you can write a CRD, which is external dependency URL. It could be the name of your CRD. Write a controller for it, that whenever this CRD is updated or created, you take whatever information is there present and jam it in the rest of the namespaces. Yeah? Simple thing. You have automated an operations task, which was reliant on a human. Now you've operated it. Obviously, unit tested it and done integration testing and everything, so you can be sure that this URL would be available for me. Yeah? And controller is the thing that you write to implement that logic, and this whole package is your operator. Plain and simple. Everybody with me so far? Any doubts, any questions? Keep them for later. So, before I start the demo, and hopefully the demo works, I promise you it was working yesterday. I promise you it was working yesterday. I'm not sure how it will go now. But before we start the demo, let's take you remember how I told you about how we operate our Kubernetes cluster, and there's a problem when you deploy things or manage things for some other teams. Like, for example, when I said we deploy and manage Prometheus and Grafana and all that monitoring infrastructure for them, all of a sudden there's a problem. They want to create alerts. So how do they do it? Because I manage it, I don't give them access. They would have to come to me, tell me, okay, do this. All right, got it wrong, they come again, got it wrong again. So much context switching. So maybe we can talk about this example, why, as an example, we'll talk about the alerting rule operator that we wrote here, and that is to address this very same problem. We manage and deploy the infrastructure, and the teams are like, how would we create these alerts? Because the shadow namespaces that we deploy, as I told you guys earlier, the shadow namespaces that we deploy, we do not give them access because we don't want them poking with it. And the other thing is, if you run that kind of infrastructure in their own namespaces, there would be some resources which would be allocated to monitoring and alerting infrastructure, which is, they get picky about it. No. So, what's the solution? Anybody can think of a proposal? I have it on the title of the slide, but anyway. So, 3 possible solutions here. The first one, human-to-human communication. A human in the delivery teams gives me the alerting rule they want to create, and I create it for them every single time. But that is not scalable. That is not repeatable. It is prone to error because there is dependency on 2 humans, me and the other person. So the first option is, do it if you can't think of anything else, but that is not an option. That's just band-aiding the situation. The second option, you can have human to software communication. So you write this alerting rules operator thing, deploy it, and then humans deploy to it constantly. That's better than human-to-human communication, but it is still error-prone. There's still room for enough error. Enough things can go wrong, and it's not repeatable either. The third option is you can do a software-to-software communication. So you define this beautiful custom resource definition with your teams can create on your cluster. They define the YAML, chuck it in their pipeline, and every single time they want to update it, it's their pipeline that updates this. That makes it repeatable. Every single time they want to do something, it will be repeatable. It will output the same results, unless you have not tested your code and everything and whatnot. But let's just assume you're writing a tested code and everything. So this is the point I want to make with today's talk, is when you automate, or not automate, when you codify certain tasks like these, which are generally considered as operations tasks, you just make your life simpler. You just make your life hassle-free. There is no dependency. Nobody's coming and hassling you constantly. There is less room for error. And there are more chances that you will succeed, and you can focus on proper things, developing features and delivering values for your customer, rather than figuring out what the hell went wrong this time. Now, what if the human you're dependent on goes on leave? What if he's sick or they are sick? There's too many variables with human-to-human communication. So, in the light of that, let's attempt to do a demo. I'm not sure how this is going to pan out, but let's just see. Okay. So, few quick things. I'm not even going to attempt the top 3 things because that is what caused my Minikube to bark in the evening. So let's just assume what I did was I just stood up a small Minikube, started a small Minikube thing, one Minikube cluster, and on that I created 2 namespaces. The main namespace is called Slytherin, and it has a shadow namespace called Slytherin Shadow. People who don't know Harry Potter, Slytherin is one of the houses. Namespace houses, no? And then what I did was I installed Prometheus, which is a stable chart. I just used help to install it in Minikube, and then we can now have a look at what actually happens. Before I start this, let me give you talk to you about the alerting rules operator proper. So, what alerting rules are in Prometheus? You can define these new things called alerting rules, which, when deployed alongside in the Prometheus config map, they set up your alert rules or alerting rules. Now, what that means is you can have an expression. So let's say your expression is my job count, running status less than 5 minutes or whatever. You can define an expression which you would normally do in any monitoring system, and then on that expression you can make decisions. If this was true for more than 5 minutes, throw an alert. Yeah, pretty simple, straightforward. Now, this is very useful from teams perspective because delivery teams want to look at telemetry data, they want to alert on certain things, and they in our case we can't give them access to a Prometheus config map, so every time they have to deploy a new alert, we can't just provide them an access because it's not possible. So what we've done is with this alerting rule operator, we defined a CRD, it's called alerting rule, and it's an extension to the Kubernetes API. And in the CRD, so when you go and create the CRD, it looks something like this. Is that visible? Yeah. I'm skipping over actual CRD definitions and what's an API and everything because that's just implementation detail. I just want to talk to you. I just want to bring home the concept that this really simplifies ops life. Anyway, so this is what the delivery team has to create. If you can see in the config block, there is an alert, there's an expression, and for that, for a severity page, just start doing something. Take an action. If the condition needs, take an action. Pretty simple, straightforward. We've been doing this for ages based on telemetry data. Check an expression. If the expression is true, do some action. If the expression is false, just do whatever. So this just helps them to create their alerts. Now, if they were to create it by themselves, if they had control over their Prometheus and everything, they would have to do something like, something like this. At first one, not this. Where did it go? Oh no, sorry. It is somewhere. Yeah, this guy, this big guy. So there is a default alert already in my Prometheus, which is deployed with the stable chart. If we gave them the control and if they had to manage their own Prometheus, there's a lot of stuff they need to know about it. You just saw the length of that YAML file, yeah? It's like, what is this? Then I have to configure all of this. I have to know about all of this. This is just ridiculous. 300 lines of YAML, as opposed to this guy. How many is it? 18 lines of YAML. So you can already see the simplicity here. From a delivery team's perspective or from a developer's perspective, the cognitive load is so less. All he needs to know, all they need to know is how to craft this. Yeah? Now, for our demo, yeah, and this is generally how you create a CRD. This is how you define a CRD in Kubernetes cluster. This just allows you to extend the API. This is what I was talking about, the implementation detail. Don't worry if you don't get this. It's not important. What is important is I can get this thing deployed. So, for the purposes of demo, what we are going to do, we've got a Prometheus. Ideally, I would like to deploy Prometheus as well, but let's just assume I just deployed Prometheus. So we have a Prometheus. When I deploy this alerting rule, it should reflect in the Prometheus UI as alert. So how many people have played with Prometheus before or know about Prometheus? Cool. So yeah, majority of us would understand what I'm doing. For those who don't, please ask me questions later. No, no. So, is that visible? So what I'm doing here is, and you can see from that error things, that is where my Minikube started passing. And I'm sick worrying now that it won't work. But anyway, let's just see. So what I've done here at the office, I've got a Prometheus server up and running in my Minikube. I port forwarded to it, so I can show you the nice Prometheus GUI. And I've clicked on the alerts. I won't click. I don't know what will happen after that. So, I've just went to the alerts tab and it has got a alert. Now if you look at this, it's called the pre-baked alerting rule, which is part of my, which is what I was showing you guys just now. So much YAML. God, only if somebody can write an alerting rule. So look at, that's the pre-baked alerting rule which you can see in Prometheus now. Now all we have to do is deploy our CRD and it should end up in our Prometheus alert section, yeah? And that's our job done. That's the simplicity here of the task is just phenomenal. So let's try this. First I start my, oh, and if you guys are interested, this, by the way, this is open source. MYOB Technologies GitHub repo. So if you feel like you want to write an operator, you are very inspired by my talk tonight, and you just want to play with it, go ahead and play with it. Pull requests are accepted. So I'll just start my alerting rules operator. Please start. Yes. It looks red, but it's okay. So yeah, this is difficult, huh? Okay, on the hand. So okay, yeah. Sorry. kubectl. kubectl. For those who are operators of Kubernetes, you would know what kubectl or K is. But K is just alias to kubectl because it's just too much to type kubectl or kubectl or kubectl or whatever you call it. It's just too much. I can't type that much. So what I've done, I've got a Minikube cluster. I've deployed Prometheus, and I've pushed just the CRD, like the initial definition of that API, on the cluster. Once you do that, you can do something like get AR on place. Now, I'm being fancy. AR is just a short form for my resource type. Like for pods, you can do PO. For config maps, you can do CM. I've created a short thing for myself as well. Why not? That's the hipster thing to do. So you can see there's no alerting rule here, and hence the Prometheus dashboard was empty, and now we're going to create one. I can't type that one, so I will copy and paste. And this deploy this here. Hello. Something happened. Good. Whoever got that, very good. Copied the wrong thing, haven't I? Yeah, this guy, sorry. This guy. It's very difficult with one hand and holding the mic and everything. I need something to play, not the really big things. So yeah, now it says alerting rule dev alert has been configured, and if I go and look at my alerting rules, there's one there, and can I go YAML here? That's the custom alert I just created. Now, if the alerting rule worked, and think of this as without, if I didn't have the alerting rule operator there would have been a person, ops person, who would have taken that piece of code from the delivery team, updated the config map in Prometheus, and hope to God that it worked. But I know it works because I tested it. But wait, before I get caught, the demo may or may not work. It's Minikube's fault, not mine. So, moment of truth, refresh the page. Hey! There it is. And it is the thing that was defined in our alerting rules. Now, I know for most of us here, this might not be really relevant. This is not really, what you were expecting or something, but the concept, understand the concept, underlying concept that we're trying to highlight is your ops life or your operations or your daily repetitive tasks, they do not have to be done manually. There's a scope of automation, and Kubernetes is just the best thing use. If you if you've ever had that issue where people get, oh shit, I forgot to update that password. That is your window of opportunity to write an operator. Write an operator and then replace their job. No, don't do that. Cool. So I think I'm almost done here, haven't I? Okay. So use cases. Now, that was a very simple demo and it's very specific to our use case. Might not be relevant for you guys, but there are a few things that might be relevant. So the other operator that we wrote, and Gus here, who's here as well, he wrote the operator initially, it's different now. What it does is, our Kubernetes cluster is deployed on Amazon AWS, which I said already, and at MYOB we have around 60 odd delivery teams. Each delivery team has a couple of AWS accounts, so that amounts to around more than 100, if I'm doing mathematics wrong or right, more than 100 AWS accounts. And the account that cluster lives in, delivery teams don't have access to it. So if they want to provision a database, if they want to use a database, first of all, we treat our Kubernetes clusters as compute clusters, at least for now. So if they want to deploy a database, there's no way they can deploy an RDS instance in our account. So another pattern could be run an instance in their account, expose it up to the public 000.0 or 0.0.0, whatever, you get my point, and it's accessible to the internet. But our database is the thing that live on the internet? No, they have data that need to protect. So this is where, again, Paul came up with an idea and then Gus implemented the idea as well. We wrote a thing called DB operator. What it does is, when you define one of those, like I did alerting rule, there's another similar thing called Postgres DB. When you define one of those in our cluster, the operator, the DB operator, provisions an RDS for you. You don't have to worry about what size I need to pick, how much data, what class I need to pick. I don't understand these Amazon classes, why they're different to EC2 classes and things like that. Don't have to worry about it. You just say, I need a database which has 5 gigs of storage and run with it. What will happen is, in 15 minutes, because that's what Amazon takes us, yeah? It's not us. In 15 minutes, you will have a Postgres database provisioned for you. Your application running on our cluster will have access. How? Because the DB operator creates a secret with username, password, URL, and everything for you. So, an operation task, we manually used to do that. We had CloudFormation script. We would create an RDS for someone and create a secret in the cluster so that they can access. But now we don't have to. We don't even think about it. Teams who need database, they just define a resource, off they go. They have the database. We don't have to worry about it. On top of that, they get monitoring for that database for free. They don't need to touch CloudWatch. They don't even need to know anything about AWS. Go for it.
I'm just interested. So for the operator to do what you're talking about, is there hooks into all sorts of, I guess, the way you're provisioning, or is it just, stop go with some loops or whatever for creating an RDS instance?
So the way we're doing it is it's pretty much stand go. We use the client Go library and everything, and then we use the AWS SDK to make out the API calls.
Okay.
And they're like event. So we provision the database and then wait for it to get up and running. There's just API calls to AWS. Now, doing that manually is very interesting, but now we don't even care about it. And it comes back with yay DBS provision. If not, it will update the CRD with the status that I was unable to provision. You figure it out. That's what we wanted to do. We don't want it to fix anything. We want it to, if you are unable to spin up the database, just tell us. Am I running out of time?
No,
okay. Awesome. The other operators, other inspiration. Oh, sorry. So you can visit MYOB Technologies public GitHub. You will find DB operator, alerting rules operator. You're free to take inspirations from those, and by inspirations I mean command C, command B, whatever you feel like. There are some other operators available as well, like CoreOS wrote XCD operator, I think, and Prometheus operator. Both of them are from CoreOS. I can't recall any others. And the last point is actually what is if you haven't followed me thus far, last point is all you need to understand. You are just limited by your, what is it, imagination. I was going to say design, but then I thought design doesn't fit there. It's imagination. You are just limited by your imagination. There's a lot of opportunity when you're operating a Kubernetes cluster to just automate small tasks, create operators for them so that you don't have to worry about those things and you can go and solve interesting problems. You can solve interesting issues like, I don't know, maybe you want to run Kafka on Kubernetes. I don't know. You maybe do that kind of stuff. You can solve interesting problems. You don't have to worry about sit there and, this resource got updated, I need to update these secret maps. No, you don't have to do that. So yeah, all it is you're limited by your design. You can code anything. Conclusion. So I've been talking about all of this. So I kind of messed up my conclusion. But anyway, let's bring this home. So, clear separation of responsibilities. Now, at MYOB, our platform team and our delivery teams have delineated separations, like we don't mess with their stuff, they don't mess with our stuff. Why? Because we provided means, which are our operators, for them to be self-sufficient in running their applications on our cluster. And we constantly working on writing more operators so that they can help, they can just do whatever they want. We don't want to be involved in application decisions. We don't want to sit there and tell them, no, DBT too small is much better for than DBT too micro. I don't care. I do not care. It's they who care, so they should be the ones making those decisions and calls. Clear separations of responsibility. And when responsibilities are separate, when responsibilities are separate, you have separate lines of support as well. I don't want to get paged when there's a database issue. I don't care. I didn't provision it, you provision it. You look at it. So it's separate. Responsibilities also means separation of support model. Now, next dependency, consistent flow. I think that is I've been just iterating over that point throughout the talk. There's less dependency on other humans, so the flow is consistent. You're not waiting for somebody to provision a database. You're not waiting for somebody to update an alerting code. You want it now, you got it now. That's it. And I think this was the idea behind DevOps, wasn't it? Sorry.
I was just going to ask, what sort of security concerns do you have about around spinning up databases in your account as opposed to theirs?
Security concerns?
Yeah.
Why we are doing this? So one of the reasons why we didn't want to provision databases in different accounts was then people would either have to access those databases out from via the internet, or then use the other thing, which is a horrible thing called VPC peering, which quite literally we don't like it. It's a very good thing, but we don't like it. So one of the choices was keep the database in their account and maybe go through some sort of crazy routing public thing, or just bring it near to our cluster.
That runs in the cluster as well.
Sorry?
The application runs in the cluster too.
Application runs on the cluster as well. Yes.
I'm more asking, like, you're running the databases in your account now.
Yeah.
So what sort of concerns around security do you have with that, as opposed to like different teams? Like they may have access to different databases like this.
They can't. Servers.
Yeah, so in terms of security concerns, yeah, so we restrict, so let's say when we provision a database, maybe I'm not getting the question properly, but I'll try to answer still. We restrict the secrets that we generate, as well pointed out. The secrets that we generate are restricted to a namespace, so the database that we provision for a particular team are only accessible by those teams. And those databases are internal, locked in. They do not have any access outside of our VPCs. So only
other teams can still see those databases.
no, they can't. They don't. Okay. So they don't have any Amazon access to our our Amazon API suite. We don't give them any access. From their perspective, from a delivery team's perspective, they do not even. So it's not a contract that will provision an RDS. It's a contract that will give you a Postgres database. How we give it, it's up to us. Potentially, we can change the implementation and run the database on the Kubernetes cluster. So other teams can't see databases of other teams. It's like nobody can see RDS side of things. Answers your question? Good, brilliant. What was I talking about? Yeah. So whatever I said so far, wasn't this the DevOps principle, DevOps philosophy? Like help your teams automate those boring tasks, remove the opportunity of failure from your system, make it easy for others to experiment and fail fast. So the operator pattern, and this was the title of the talk, not the presentation, but the operator pattern in combination of CRD helps you do that. It's a win-win situation for all. And at that note, I think this is my last slide, but at that note, oh yeah, this one. So we are a bunch of crazy engineers who love doing interesting things. MYOB is a place where autonomy and there's enough cadence to innovate and work with bleeding-edge technology. If you are willing, or someone who wants to live on the edge, have that rush every time, join us. We are hiring, and we love dumplings. Thank you very much.